So we've done all the things so far with right triangles and solving right triangles, being able to find missing angles, missing sides. Well, what if we don't have a right triangle? And so there's two different things we can do if we don't have a right triangle. There's the law of sines and the law of cosines. And today we're going to look at the law of sines. So the first thing we're going to look at, though, before we actually get too far in the law of sines, is talk about area of a non-right triangle. Now, we know that to find the area of a right triangle, that we will multiply 1/2 base times the height for the formula. And if we have a non-right triangle, though, like in this picture with this the sail, that we can see that we have this triangle here. They know this information, that side C here was 2.96 meters. The angle A is 73 degrees, and this base is 2.13 meters. Well, we can find the height, which is what we need to be able to finish the area formula, because we have the base is 2.13, and we need to find the height. Well, to find h, we actually know the 73-degree angle, A, and we know side C. So we could set that up that the sine, of 73 is equal to the opposite over the hypotenuse. Okay? And so to find h, we would take the hypotenuse and multiply it by the sine of 73. So if we set it up so it's like here, the sine of A is equal to h over c, and we multiply both sides by c, we would get the height is equal to c times the sine of A. Well, here's the way it works. That if I know, let's go here. If I know an angle, okay, and the two sides that make that angle, okay, that form that angle, all right, then I can use this formula to find the area of a triangle, because I'm just doing 1/2 base times height. 1/2 times the base, and then the height is found by doing the hypotenuse of that right triangle times the sine of that angle. And so if you look at this formula down here then, that they've written it in 3 different ways, but all 3 of those ways just reflect if I know an angle and the two sides that make that angle, then I can use this general formula by plugging those numbers in. So if I know angle A and sides B and C, I can do 1/2 B times C times the sine of A. If I know angle B and sides A and C, I can do it. If I know angle C and sides A and B, then we can use that formula to find the area of a triangle. So basically, if I know two sides and the included angle is another way of putting it, and we'll talk about that more when we do the law of cosines, is that I can find the area of the triangle by using this formula. So here we have a triangle that has one side 5 meters, another side 3 meters, and the included angle is 40 degrees. And they want us to find the area of the triangle and round it to the nearest tenth. So like I said, the thing we're looking for is side, side, and then the angle between them, okay, that those two sides formulate. Or you can think of it this way, that I know this side here, and what angle do they make? They make the 40-degree angle. So I know those 3 things, and that's what I want to use to find this. So the area is equal to 1/2 times 5 times 3 times the sine of 40. And really the order you put the 5 and the 3 does not matter. Because we're multiplying and it's commutative. Let me just plug that in our calculator and make sure I'm in the right mode, and I'm not. Make sure I'm in degree mode. So 1/2 times 5 times 3 times the sine of 40. So 4.8. So the area is approximately 4.8 square meters. Because if once again, if we looked at this, put a right triangle there, then 3 times the sine of 40 would give me the value of h. So we have 1/2 times the base, which is 5, and 3 sine of 40 is the height then. Find the area of the triangle. Okay. Now, the law of sines then. If we want to find the missing parts of a triangle and a non-right triangle, then in some situations we can use the law of sines. Other situations we use the law of cosines. And actually in this situation here, where we know, we talked about this, if I know two sides and include angle, okay, that's actually, to find the missing parts there, we're going to end up using the law of cosines, and we'll talk about that on Thursday. But today we're going to look at the law of sines, and they've actually taken the area formula and they've used that to create the law of sines. So if we look at this formula, just to kind of show you how it comes about, that we know the height can be found 3 different ways, right? Okay, depending on which two sides and angle you know. So if we multiplied through by 2, okay, that would get rid of the fraction. And then if we divide by A, B, and C, okay, the 3 sides. So if we divided by A, B, and C then, each one of them, that it would simplify to be this right here, which is the law of sines. So you're going to want to write this down. Okay? And this is a very important reminder here. Angles are always represented by capital letters, and sides are always represented by lowercase letters. So we're going to do the sine of angle A over side A. That ratio is equal to the ratio of sine of angle B over side B is equal to the ratio of sine of angle C over side C. And then not only with that then, this is when we use the law of sines. That it can be used when we know either of these two things. We know angle, angle, side, or angle, side, angle. Okay, you remember that from geometry? When we were proving congruence of triangles, that angle, angle, side was one way, and angle, side, angle was another. So like if we're talking about angle, angle, side, that would be like we know angle A, angle C, and side A. Okay? That would be an example of angle, angle, side. And angle, side, angle would be like knowing angle C, side A, angle B. So now also, two side lengths and the measure of an angle that's not between them can be, we can use a law of sines there. But now, can you prove a triangle by side, side angle? Do you remember? No. Okay. And I always say that that the only way you could prove a triangle using side, side angle is if you can spell it backwards correctly. Okay. So it only works if it applies. Okay. If the spelling of it backwards applies, then you can use it to prove two triangles are congruent, but otherwise you can't. Okay. Makes sense, right, Lauren? I guess everybody else is asleep because it seems like you're the only one who got it. Okay, Jasmine. All right, so here we have a triangle, and they want us to solve each triangle. When it says to solve the triangle, that means we're finding all of the missing parts. Okay? So they give us two angles in the side. We need to find the other angle and the other two sides. So here, let's see, what do we know? We know a side, and we know two angles. So we know angle, angle, side in this case. So we can use the law of sides. So I'll set it up, except I'm going to set it up with the letters that they give me. So I'll say the sine of D over side D equals the sine of E over side E equals the sine of F over side F. So the first thing I'm going to do is I'm going to write out the formula using the letters that they give me. And do you have to do this? Not necessarily, but it helps me make sure I put everything in the right spots. Okay. And then I plug in what I know. I know angle D, so I'll put 33 in there. Don't know side D, so I'll just put the lowercase d there. Don't necessarily know angle E, so I'll just write sine of E, and I don't know side E, and I know angle F is 28, and side F is 15. Because side F, the side across from angle F, is 15. So we need to find side D, side E, and angle E. Can we find any of them? What's the easiest one of those to find? Angle E. And how come angle E? Okay, because they all add up to 180 degrees, right? Okay, so 33 plus 28 plus the measure of angle E equals 180 degrees. So what does that make the measure of angle E? 119. Okay. So we'll say the measure of angle E equals 119 degrees. Okay, and then we're going to find side D and side E eventually. Okay. So I can put 119 in here for angle E. Now, how many of you know how to solve proportions? Okay, we all do, right? Okay, so we did in the warm-up. And so now this is just a matter of solving proportions. Okay? We have one ratio that we know, sine of 28 over 15. And since it's equal to both of the other two, then I can put it separately with the other two and solve. So we'll put it with the D's. And put it with the E's. And then cross multiply. So we get D times the sine of 28 equals 15 times the sine of 33. By cross multiplying with the one on the left. 15 sine of 119 equals e times the sine of 28. So notice in both cases, what am I dividing by? Okay, all right, and that should always happen here then. Dividing by the same thing. So when they're looking for our answers rounded to the nearest tenth. So D is approximately, and E is approximately. So the one thing is, if you write it like this, then make sure that you, when you plug in your calculator, you use parentheses correctly. So 15 times the sine of 33, close the parenthesis, and divide by the sine of 28. So letter D is 17.4. And do we have no specific units? And E then is 27.9. Now, one of the things I want you to look at here then is the fact that compare the side lengths with the angles, okay, for a moment. Here's a little checking mechanism to make sure that you have done it correctly. That what should I know when I compare angles and sides? Anything? If I'm trying to estimate, yeah, I probably answered this correctly because this thing is true as far as the angles and the sides go, as far as their sizes. Okay. Okay. E is the longest. Why would E be the longest side? Because what? Well, it's not the hypotenuse because you only have a hypotenuse when you have a right triangle. Okay. But it's the, it looks like the longest. And the reason it looks like the longest is because angle E is the largest angle. Okay. So the longest side is always across from the largest angle. Smallest side is always across from the smallest angle. So in this case, my largest angle is E, so my largest side should be E, and that is the case. Okay. 27.9 for side E. So then angle D is 33. That's the second largest angle. So then side D should be the second longest side. And it is. D is 17.4 and F is 15. So just a check that you can do is make sure that all those things are correct. And if they are, then okay, that's a quick check for you. Okay. All right, let's go to another one. Here they want us to find the missing parts or solve this triangle here. So once again, the first thing I'm going to do is set up the the law of sines using the letters that they give me. Okay, yep. So this should be, there's a little mistake here. This should be a Q here, and should be a little R there. Good, yep, something to check on. So we will have the sine of P. I'm going to go in alphabetical order. Does it matter if I do or not? The answer is no. Oops. Now the other thing is that actually these ratios could be written the opposite also. You could put the side lengths in the numerator and the sine of the angle in the denominator. Okay? It could go either way, because as long as those ratios are still going to be the same if they're all the reciprocal too. So once again, they give me two angles, so I can easily find that third angle, right? 36 and 39 is 75, so angle P would be 95 degrees, right? So the measure of angle P equals 95. So then we need to find side Q and side R, approximately. So plug in what we know. What? 105. Are you sure? Okay. 75. Okay. All right. Just checking you. Make sure you're paying attention, not agreeing with me all the time. Do you believe that? Okay. All right. That's all right, because yesterday Nathan and Kayla were working together, and they finished the rest of that handout we were working on, and I'd actually added correctly when I did the perimeter of that one triangle. I had put 260 and 270, so off my game this week, I guess. All right, so sine of 105 over 10 is equal to the sine of 36 over side Q that we don't know, and sine of 39 over side R. So since the largest angle is 105, that means the longest side is 10, so Q and R better be less than 10 when we're done. Okay, if they're not, then we made a mistake somewhere. So we'll use the ratio that we know with both of the other two to solve for the missing parts. So sine of 105 over 10 is equal to sine of 36 over Q. Sine of 105 over 10 equals the sine of 39 over R. And then just cross multiply. What'd you get, Lauren? And 36-degree angle gave me 6.1, 39-degree angle gave me 6.5. Makes sense. The longer angle is going to give me the longer side. But they should also be close together, right? All right, since 36 degrees and 39 degrees are very close to the same size, and these numbers should be very close to the same size also. Just a good check there. Not too bad, right? All right, so we got one more thing to look at, still using the law of sines. But there is the problem of the situation with side-side angle. Now, the reason that you can't use side-side angle to prove triangles are congruent is because it doesn't always work. Because there's actually three different situations that could happen. There could be no triangle with specific side-side angle measures. There could be one triangle, which is, quite often the case, or sometimes there could actually be two triangles. And so side-side angle gets a little bit difficult because of that situation there. And here's what they look like then. So if we're given sides A and B and the measure of angle A. So we're given two sides and the angle that goes to one of those sides. And we have two different situations, one where the angle A is acute and one where it's a right angle or obtuse. So if angle A, or if side A is less than the value of h, and where do they get h? What's h in this case? What's h refer to? Okay, the height, all right? And we know we were working on finding the height in the problem with finding the area of the triangle. So the height, the value of h, is found by doing b times the sine of angle A. Okay. The hypotenuse times the sine of the angle. So if A is less than the height, there's no triangle. Because as you can see, it's not going to meet this line down, other line down here to form a triangle. If A is equal to h, then we have one triangle. It'll be a right triangle. If A is greater than the height, but less than B, then you can actually have two triangles. Okay? Because if you're looking at doing constructions, okay, then if I did the construction here, that I could either end up with this green triangle here, oops, or I could end up with this red triangle. And where both of these sides are the same there, value of A. Okay. So you could end up with two triangles in that case. And if A is greater than or equal to B, then there's only one triangle. All right, so they have those four possibilities whether it's an acute, when angle A is acute angle. And all you need to do is compare the values of A, B, and H. And if angle A is a right or obtuse, if A is less than or equal to B, there's no triangle. And if it's larger than B, then there's one. So you don't have to worry about two triangles when it's obtuse, at least. So when we're given a situation where we know side-side angle, the first thing we want to do is find the value of h, and then compare A, B, and H, and see which situation we're in. So here they want us to determine the number of triangular banners that can be formed using the measurements A equals 50, B equals 20, and the measure of angle A equals 28 degrees. Then solve the triangles and round to the nearest tenth. So we want to, so the first thing we're going to do then is we're going to find h. And then we can compare a, b, and h. So h is b times the sine of a. So in this case, that would be 20 times the sine of 28. Which is equal to what? 9.4. Okay. So when we're comparing them, as far as sizes, we have h is the smallest, h is less than, then b is the next size, and then a. Okay? So a is the largest. So then we're going to go up here and we're going to look at this chart. Let's see. The first one, a is less than h. Nope, that's not true. Second one, a is equal to h. Nope. Third one here, for two triangles, a is between h and b. No, that's not the case either. But a is greater than or equal to b, so there's one triangle that can be drawn here. So let's just draw what could be the triangle. All right, so here's my horizontal piece here. It says b is 20, measure of angle A is 28. So if measure of angle A is 28, then probably only about that size there, right? Okay, it's a smaller angle. Okay. And when I compare, if A is 50 and B is 20, that means that side A then, my side A is going to be about 2.5 times that, isn't it? So it's going to come down here. So my triangle is going to look something like this, where we have, here's angle A, here's side B, side A, and so that means this would be angle C and angle B here. Okay. So we're always going to set it up this way. We'll draw a horizontal line then, okay? And then approximate our angle A and put side B there. And then we'll take side A and attach wherever it's going to be on this horizontal line. So angle A will always be your left angle over here. Angle B will always be the right one, and C will always be the one on top then. Okay? And if you set it up that way and think about that way, it'll be easiest. Okay? So what do we know? We know this is 28 degrees. We know B is 20 and A is 50. So since we know two sides and an angle, we're going to use the law of sines to find the rest of the triangle. So I set it up using A, B, and C, plug in what I know. Now we don't know anything from the third one, do we? Okay. So we're going to have to solve the second one. Solving the second one will give us angle B, so then I'll know two of the three angles. So then I'll be able to find angle C and then side C. So we get 20 sine of 28. And we can just leave the 50 there, right? In this case. That equals the sine of B. So how do I find angle B then? Do what? Solve the left side. Okay. So let's see what we get when we do the left side. 20 times the sine of 28 divided by 50. All right, so we get 0.1878. So is that angle B? 0.1878 degrees? No? So what do we need to do now then? Right, we need to do the inverse. So the inverse sine of 0.1878 will give us the value for angle B. Okay. Now I want the most accurate number I can get, right? Okay. So really the most accurate number I could get would be if I put 0.1877886.251 in there, right? Okay. How can I easily put that in here? Anybody know? Okay. All right, do what? Oh, look at that. Okay. You know what? I didn't know that either. Good work, Thomas. Okay. Yep, because that's what I would have done too. Jenny is a hit second and answer, but now we know. We can scroll up there and do it. I did not know that. Okay. So good work. 10.8. So angle B then, 10.8 degrees. So let's see, 28 and 10.8 would be 38.8, right? So that means the measure of angle C is equal to what? Okay, 141.2 degrees, right? Because the three angles have to add up to 180 degrees. Right? So then we're going to find side C. So the sine of 28 over 50 will equal the sine of 141.2 over side C. So what's side C? 66.7. You got agreement with that, Lauren? Okay. And let's see, that's in, what does it say? All right, units. Now it makes sense that that should be a lot longer, doesn't it? because we have a 141 degree angle compared to a 28 and 10 degree angles. So that 141, so side C should be quite a bit longer than the other two then. So the law of sines then, we're looking at knowing the, what do you know? Do you know angle, angle, side, or angle, side, angle? Okay. For them, if you know those two things, you just plug it in, write down your law of sines according to the triangle they give you, plug in what you know, and then use the ratio that you know with the two that you don't know completely, and put them together and solve. And if you know side, side angle, then you need to find the value of h, compare A, B, and H. How are they related? Determine how many triangles we have. Now, the thing is what if we have two triangles? Okay. If you have two triangles, then you actually have two angle B's. We would have the measure of angle B1 and the measure of angle B sub 2. Okay. Now, the big thing is, how are those two related? And they're supplementary. Okay, those two angle B's are supplementary. So these two angles, the one here and the one here, are supplementary. And what does that mean, to be supplementary? If I remember what supplementary angles are? Right, they add up to 180 degrees. So if the first angle you're going to get will be less than 90 degrees always. So then to find the other one, you would just subtract from 180. And what would happen then is you'd have to find, once you find that second angle B, or find angle B, we would do it the same way we did that one. Okay, find angle C and then side C. But if you had two triangles, then you'd find the second angle B, and then you'd have to find a different angle C and a different side C then. Okay. But all the work you do is the same. But I think I actually set it up so you only have to worry about today anyways. Doing each one that you're doing only has one triangle. So, okay. Questions?